day of the conference IEEE DESSERT'. It's my pleasure to invite you for our plenary session number 5. Previous 2 days were very interesting, very resultative, because we had possibility to hear about 50 reports. Today we will finish after this plenary session and two topical session. During this plenary session, we will hear two very interesting talk. It is more industrial talk, more practical talk, and it's my pleasure to invite for first plenary presentation our friend Dr. Mario Fusani. He is a research associate with the Information Science and Technology Institute of Council of National Research in Pisa, Italy. Mario has been working since 1973 in this institute. In 1986, he founded the System and Software Evaluation Center in the same institute, Active Science then. He has been working in various international working groups for standardization. He is one of the most famous specialists in European area requirement engineering, standardization, and so on. I'm happy that we performed for a joint project with Mario and his institute. His current research interest is in software-intensive system safety assurance and in safety-related standard comparison and evaluation. I would like to invite Dr. Mario Fusani for his presentation. Welcome, Mario. Please.
Thank you. Thank you very much. And I'm very pleased to participate in this issue of the DESSERT conference. Thank you very much, the chairs and the organizers who succeeded in this very important task in this very difficult time. And I'm going to speak. Let me just turn on. Okay.
Please.
Just a moment. I'm sharing the. Now, okay. Okay, there's a moment.
Please click Start Sharing and select entire screen,
yes.
And then confirm that.
Can you see the screen now?
Yes.
Oh, okay.
Absolutely okay. Welcome, Mario.
Okay, thank you very much. And this talk is going to be on quality of standards, and this is a topic I'm carrying on for years, not continuously, but from time to time at the Institute of Information Science of the National Research Council of Italy in Pisa. And I'm going to talk about quality of standards and how you measure quality and why quality is important. And then I will speak of means to measure quality and the purpose for doing all this, and also introduce a more updated mean to measure quality and to understand how not just the standard but the quality on the way standards are made. Okay, let's start with why. In my opinion, and in opinion of other researchers, quality of standards is important because standards are a common reference for doing for building products and processes able to build the products, and so the quality of the standard is reflecting, is having an impact on those products. And if when products are safety related systems, equipment, that is very important. And they have impact on our daily life, a very strong impact. So quality, by these property qualities of standards, has got an impact on our daily life. If perhaps people do not realize this, but this is my opinion. And who is interested in this? Okay, you say how very few people can be interested in this because high quality of standards. There are guides. There are standard worldwide organizations like ISO, IEEE, and SANELEC and others. They issue guides for making standards, guides to be used by the international working group that makes standards. But those guides are related mostly with the way how to structure the standard. They also say how to wording a phrase, how to paragraph, and so on and so forth, but are not very oriented to quality. And this fact of some lack of quality of standard was addressed also by scientists during the years. One important paper was many years ago of Norman Fenton, professor at the City University in London. He published a transaction software engineer entitled "A Strategy for Improving Safety Engineering Standard." That means that this improvement means that it was understood that there should, at that time, something should be done to improve those standards. But this practically this situation is still carried on up to the present because very little effort has been done. There has been this problem has been addressed also by a group of experts working in avionics standards. They made a workshop in 2014 about that to assess the efficacy of standards. That was a very important one. And there was also NASA in there interested in safety of the space vehicles. And the results was, well, okay, we should do something, but it was not clear how to do, what to do. And then NASA published a report in 2015 about the same thing. So, as I said, not very many progresses were made by that time and after that time. So, but recently, conveners of international expert working groups expressed the willing to express to our institute, the willing to try to have rules, methods, and possibly tools to assist standard developers. And they were interested in the history of research carried out at our institute in Pisa, National Research Council, starting back from 95, when this research line is related to study the natural language aspect of requirements. Requirements are mostly expressed at the first time. Requirement is pop to your mind is expressed in natural language. Then is transformed in formulas, in more formal expressions. But at the very beginning, and this is the point, the very beginning is expressed in natural language. And there was, I'm not going to detail, but during the years, this problem, this research line has produced a couple, 2 or 3 tools to analyze and possibly to improve the natural language expression of requirement, mostly software requirements, but requirement in general. But when the DESSERT conference started for me in 2009, I started to put this the attention of this research to special requirements that are in the standards. Requirements of standards are called clauses, and especially with shall type clauses. What people must do to so that the equipment and the processes expressed in the standard are conformant to the standard. And very recently, I'm trying to collect with the help of conveners from IEEE and CENELEC a literary corpus to analyze with a more modern methods the standards in order to discover how this can be, how this goal can be achieved. That means improving the standard, but with the in what aspect? So what is the quality standard I'm speaking about? Well, sorry, we have to turn our attention to quality models. That quality is a set of attribute of features. Anything has to reach its purpose, and so applying some quality model engineering. I'm not going to details about this. To standard, we can say, for instance, who are the users? Users are developers of products and processes, but also the assessors, but also standards developers themselves, because a standard gets improved once in a few years. And so the qualities coming up from the model are, and also in the first paper by scientists in the late 90s, the problem of ambiguity was raised, and also the problem to easy understandable and to application to the projects for developer, and also the problem of easy understanding of standards by the assessors. And there are some different aspects of those, but I'm not going into this way. I'm going to speak about the way to measure this quality in this talk. And there is also the problem of how to get the standard up to date with the state of art, and in the same time to be a reference, a stable reference. So there is a trade-off in this, and also the trade-off of the standard about having requirements which are not dealing with the way to implement, but should address also the techniques. Say this techniques is better than that, and this is another trade-off. But back to the problem of ambiguity, of trying to get to understand the point of the aspect of the standard related to the easiness to be understood. In the year, at our institute some a quality model for standard for requirements, and which I try to apply also to standards. Pointed out some aspects of the text of the language, natural language, used to express the requirement, and some characteristics were pointed out. This is a partial list of those. We have implicity, that is when we express if needed optionality, the option of people, or subjectivity, what is simple, what means known, and vagueness, what means for vagueness, what means easy, what means edit. But these words happen in the standard, and I can show it in a moment, and so on, and other aspects. But I'm not. This talk is not addressed to this aspect, but they use this model in order to explain a way. I'm trying recently to use to understand the way the quality of the way a standard is made. For measuring the requirement with at my institute, it was developed a tool called Quartz, quality analyze requirement specification. And this is the user interface, but just to tell that we can with this button we can choose the characteristics to be analyzed. We put a file, some file of text of the standard in a section of the user interface, and we select which aspect to analyze, and then we get a report. These are a scrolling window, so we can use tens of thousand sentences in for analyze and for the requirement. We will also just to tell you, try to adapt this this tool to analyze some project containing million of requirement, but this is another story, but still related to the quality. So we using this tool. We had used the tool in the many years ago to analyze some popular safety-related standard. Like this is a for nuclear power plants, for avionics. This is for railways. This is a very popular standard, and for general safety-related products and processes. This particularly about software, but this were the results. All the aspects, vagueness, multiplicity. Okay, there are many of those. I have to say that some of these are false positive, and so a manual inspection is still needed to eliminate the false positive, but the report usually are interesting, and the conveners of standard just agreed that this could be a way to better understand the standard quality. And but the point is, from last year to now, I try to look where the problems of the quality in standard is starting. It started with the very beginning. The standard is written, starting with the first draft, because those are the final draft analysis. But I think it would be important to look at the first versions of the standard when people is discussing, and then it is possible to intervene to improve the standard, to improve the quality of the expressions in order to have a final version more acceptable, more understandable, and with less ambiguity as possible. And also, besides the draft of the standard, we have in the beginning, during the process of making the standard, we have many comments from experts worldwide, because a draft is circulated in all the universities, in companies, and all the environments that are interested in using the standard to develop projects. And so we get for each standard thousands of comments. The comments refer, this is an example of a line of a comment sheet to analyze a standard related to railway. And in the comments there, the clauses are identified, and then there is a kind of comment, general, technical, editorial, and comments. The comments say what is not acceptable from the point of view of the expert, and some changes are proposed. And this is important so both the comments and the draft text of the standard are data. They are data on which we can perform our analysis. We need to do it automatically, of course. We need engines to extract the clauses from the standard. Usually they are PDF or Word documents, and put this information, this data, in a way can be analyzed by a tool. In this case, we are using our Quartz tool. And also we get also the comments, we extract the comments and try to use the comments as data. This I'm going to show an example of an analysis of a standard, of the draft standard. This is a railway-oriented standard, 5128. For the final issue was made in 2011, but I'm using the 2009 draft in order to perform, and the comments of experts, in order to perform this analysis I'm going to show. Okay, this is what we get from the first part of the analysis. We are going to, this is a data frame, actually, consisting of clauses identification. In this case, I have, for this draft of this standard, we had 261 lines. And these are the qualities of, I pointed out before, detected by a tool, let's say non-quality, the possible defect of quality. This vagueness, subjectivity, multiplicity, optionality, weakness, word and sentences, which are such problems. Okay, it is a very sparse matrix, but you see the multiplicity, and the tools point out in 261 clauses an interesting bunch of possible defects. And this is an example. Perhaps this is a portion. This is a portion of the output of the tool. In the horizontal line are all the clauses. You think of 261 clauses in this example, and these are the cardinality or the frequency, depending on the way we want to process all those data, of each possible defect. And still we have this defect list. And this is what happens in all the clauses of the standard. And so these are data we are using for our analysis, and we want to compare this data coming from the tool analysis, data coming from the expert judgment. So we are going to extract, this is an example. I have a list of words that indicate the expert is not accepting each clause he is examining, and in the text there are words like this: cannot, wrong, change, misunderstood, and there are sort of 100 of these words. And so we can have a metric to extract data, processable data from this, and measure the number of words in each comment, or the density of word in each comment. And so we get a more complete data frame, which we have here. The clauses of the standards, clause identification are here, and still in this example 261 lines. We have the results of the tool analysis, and we also have the information taken from the expert judgment. And so we can set this data frame as a data set for using the machine learning algorithms. This is the process. So we have the source of data, which are documents, PDF or Word documents of the draft standard. Here we have sheets with the lines, with the comments of the experts. And I said we process this. I got a data frame with some engines that extract the clauses and they put in a structured way. And this the same. We have an engine which extracts the words and the frequency of the words that are indicating that each clause is accepted or not accepted. So we have this data frame I showed before, and what we can do here is to consider this scores or expert judgment normalized in the way I said as label of feature, where the feature are the results of the quality analysis made by tools, and as frequency we have this frequency, and we can, for each clause we can ask, is there any relationship between what the tool found and what the experts found in each clause of the standard. So we can consider this a data set labeled, where the labels are the decision of the experts on each clause, and the feature are what is coming from the analysis of using the tool. And we can to check if there is any relationship between those, of which kind of relationship. We can train this data set with several possible algorithms of machine learning. When we train this, any algorithm is creating a model in such a way, if we feed with new draft new draft analyzed by the tool with the score of the analysis and new comments coming from the expert, we can feed that in the model and try to predict if the relationship holds, the relation we think we have found with this during the training phase is hold. If it's hold, we can, so with the comparison of this, we can do correlations of other comparison. And if this holds, we can use this. We can use it, and the standard maker can use this. I will get to this shortly. So, as I said, we can call the expert judgment as a label, and this is a data frame coming from the tool analysis, and so we can do an experiment here. So we can consider since I didn't have a new standard to shortly to analyze it, so I did what usually is done with it. We divide in two parts this our data set. This is 60%. This is 40%. 60% we use this for training algorithm, and this is for testing the results of the training. This is tests. So this is the data. Training set, and this is the test set. Here we have 150 lines. Here we have 100 lines. So this is not very big. It's very small from the machine learning using point of view, but I am sure this is an experiment as a demonstrator. So we have the labels for the training set, and the label for the testing set. And the question is there a relationship between this matrix and this column, which can tested in the testing part? So if we apply the algorithm here, we predict something, we will be comparing with this. So if X is giving Y, X1 is giving something to compare with this. Okay, these are always labels provided by the expert. This is the expression using on the training set an algorithm. This is actually it's a classifier algorithm. This is a classifier used for classification, but I could have used it also linear regression algorithm. But this is proven to work with the mock-up data, and I thought this is our real data. So we get these results, and this is the prediction, and this getting from applying the algorithm. This is in this we train the data as those data with these results, and here we predict in the test set, using the test set, we predict the output, and this is the output. We compare this with that. This is done by the algorithm. This is done by these are the expert score. So this is the real judgment, and this is a forecast of the judgment on the same data. So we can do a comparison, but this is, I have to say, this is the way to do a comparison. But in this case, I'm not believing that this is very meaningful, because we have very few data and we have a sparse matrix. As you see here, the lines have been shuffled. They are not in sequence, shuffling here and there. But when we shuffle, if the matrix is very sparse, we can get different results. And if you try again, I can find a slightly different correlation for it. This is sort of a correlation, but I do not believe in this correlation now with this very, very small sample. This is just for showing the how we want to do the job. So conclusion, I wouldn't say this conclusion because it's a work started a month ago, less than a month ago. So I collect data and I put together and trying to use the machine learning algorithm, very simple machine learning algorithm, and then basically they are linear regression algorithm for now, and can progress in where the job is going on, the line of research is going on. We can try to collect more comments, and the convener promised me to have more drafts, which we analyzed up to have up to several thousand of comments. And in this case, we can check again, trying to change algorithm, try to better the quality analyzer, to do some sensitivity work and extend the quality model with the new words and so on. And we also can try to partition the comments between. But this is we are looking mostly to the influence of editorial, but we have some ideas about technicals and use a better tool. And in the end, we try to skip the quality analysis and to check directly from clauses to expert comment, if to check if there are some not evident hidden relationships with the way the clause is done and the comment by the experts. So this is what we are going to do in the next years. And this experiment is just started. So this is just what I showed is just a hint of how the thing can be done, but we'll change. We'll try to improve the process as well. Okay, this is end my presentation. I hope you didn't have problems with that. And if you have questions about.
Thank you very much, Dr. Mario Fusani. Thank you very much, Mario. Now we have time for questions and answer, for discussion. This is very interesting topic, very important topic, I think. Any questions, please? Okay, maybe I'll start. Mario, I have two questions. First one, related to artificial intelligence area, AI, as model, as algorithm, as AI-based systems. We, during last year, analyzed standards, not formally standards, it's different regulatory documents related to requirements to AI and AI systems. It concerned NIST, IEEE, UNESCO, and other high-level documents. And we saw that there are a lot of contradictory in not only requirements, in hierarchy of characteristics. I think it is the main question in context of quality standards assessment is the right hierarchy, objective hierarchy. What about possibility assessment these issues for assessment of standard, correct standards hierarchy? Thank you.
Okay, thank you for the question. This is this is a very nice, a very good question, and it's a very important problem. But this is a step forward about our research, because the topic I was speaking about is related to locally to each local clause. So possibly problems internally to a clause and to one requirement, and possibly some relationship between the two requirements, with the requirement and the requirement that are preceding this requirement. Getting in a more an abstraction level up, this is very important, because also the conveners of the standards ask the question very similar to the one you asked, and of course our tool are not addressing this. Our tool addresses the way a single requirement can be understood. But about the organization, the hierarchy, this is another problem. We have tried to think of it, but still at the very beginning. And I know there are researchers more advanced than ours on this, and we hope to get information, to get data from those environments. But it's not our case so far. sorry, but this is out of our reach for now.
Thank you. And my second question related to expert team who involved into preliminary analysis and preparation of data sets and so on for your tools and for your technique. What is your opinion about weights of industry experts and the more academician expert to assess quality characteristics? I mean, for practical specialists, maybe more important to have strongly verified requirements. I mean, more quantitative requirements. One of the best standards which I know is the standards IEEE 15408 related to security guarantee. What your opinion concerning balancing of experts understanding when we form requirements of new standards? Thank you.
Oh, thank you for the question. I don't know how it's close to what some people I know in my institute and among the conveners of stand. The question is very, again, your question is very similar to a convener of a future IEC standard told me just a couple of weeks ago. And he said, we have this problems, and we would like to have more expertise before issuing the next version of each standard draft. And I said, I think a team of experts should be made, but what I will need for instance, my project to extend the reach of and also the environment of the analysis is a team composed of necessary one data scientist. I've used the data. I'm in machine learning, but I'm not a data scientist. I'm so expert of standards, but no, I'm not a data scientist. I need and also I need a programmer, with in this case able to process it text. I use personally some Python stuff, Python libraries, because they are providing many way to analyze and to process text. So I need programming, and so a data scientist is important. A programmer, I need a standard specialist, and I need or security and or safety expert in the team. The team is necessary to devise a method and possibly tools to be used. But a method may come shortly. Making a tool is another story. Making a tool is quite a job, and a finance project is needed. But trying to devise a method which is going to be use existing tools can be done. For instance, to address your problem you said before, there are tools performing clustering. When you perform clustering, you can also try to find a hierarchy in those in the result of clustering action. And this was not my opinion, but I share this opinion that can be done. So we do not have anything ready by now. we need to put together some competencies, you said, as you asked, and I am proposing. And but it's going to be interesting because I have to meet again a couple of convener. I will try to organize a team which is going to work and to proceed in this research line of standard qualities, which is perhaps it's not interesting for many people, but for convener it's interesting.
Thank you.
Thank you.
Okay, one more question. The question about possibility of AI. We know that now AI writes music, writes poems, and so on. What is your opinion as expert in area standards in engineering? Can AI develop standards?
Sorry, can AI?
Artificial intelligence can artificial intelligence write or develop standards?
Well, I think so, but I think it did a very long research line to do that and attempts. But I am positive on this. I am positive because analyze a very large. You can find patterns to be used to also to make a standard. But any project I'm seeing is. I see any project I can figure out would, in my opinion, would have a person in the loop, at least a person in the loop, assisting and try to oh, this is good, this is not good, because AI doing completely this. But I'm not an AI expert, so I just try to use some results of AI work to do my and to progress in my research, current research. Thank you so much.
Thank you. Thank you very much, Mario. Any questions? Other? No, I don't see. Thank you, okay. Mario, one more for your very interesting talk, very interesting presentation. Hope for our future cooperation. And now we, sorry.